Hello, we are Group 25, and our topic is about the crimes in data visualization of crimes in Los Angeles. And Haoran and M stands for the dataset and methodology.
And my name is Ying Zhao. I will introduce the introduction part and conclusion part.
Hi, I'm Hongwei Sheng. I will explain about the results we had.
So, our topic is data visualization of crimes in Los Angeles, and the presentation today includes introduction, dataset, methodology, result, conclusion, recommendation, and reference.
Criminal incidents are common problems faced by the whole world. With the continuous development of the world situation and the increased complexity of human beings, various contradictions, crimes are consistently emerging from drug injury and killing, theft, and robbery traffic accidents. It seriously affects the security and stability of countries and regions. With the rapid development of the Internet, big data has provided some new methods and ways for police department to reduce crime rates and prevent crime. The value of big data is not how much data we have. The data itself doesn't make much sense. Its significance is how we can effectively use this data. We choose crime data from Los Angeles to study. The figures shows that Los Angeles overall crime rate increased by 5% percentage in the 2010 to 2016. Property crime increased by 4%. Violent crimes have increased by 8%. In other parts of California, property crime rates fell by 6%. Violent crimes fell by 2%. The overall crime rate in Los Angeles has increased by 27%. Our research analyzed the distribution of various crime types in Los Angeles by visualizing data from Kango. Use data combined with data visualization software to display the type of crime in each region and the overall distribution of crime types on the map. This is always the first and the more important step in conducting crime analysis. It is a bias for the police department to predict crime.
So the second part of our presentation is a data set. We collect our data from a trusted science platform called Kaggle, and our data set size is more than 1 million from 2010 to the present. And the attributes of our data sets include time occurred, victim gender, area ID, victim descent, area name, weapon use code, crime code, weapon description, new crime code, criminal code description, MO code, victim age, and location. So I'm gonna give you a brief introduction of our important attribute. First one is area ID. So the area ID is based on the location. We just grouped the distinct of Los Angeles into 21 areas, and each area ID stands for different distinct in Los Angeles. And here is our map of LA districts. And the second important attribute is crime code. So previously we have more than 40 crime codes, and we group them into new crime groups, and which is 23 groups based on their crime description. So let's talk about the methodology we choose. Here is our flowchart. First, we just gathering information from the internet or some society news, and we choose our topic to do the crime in Los Angeles of data visualization, and we collect data from cargo, do the data pre-processing using Excel, Access, and KNIME. And we choose 3 kind of data visualization tools, such as Infogram, Table AU, and Photoshop to complete our research. So first, for the data pre-processing, we use Excel and Access. We replace our previous crime code into a new one in Excel and Access. And Table AU is used for geographical analysis of our dataset. We use that data visualization tool to insert our data into the LA maps and see the different crime types in different districts. And we use Photoshop to edit our logos, which can be added into the district. So here is our logos. We have 23 kind of crime types, so we just create 23 logos for our crime types. So let's welcome my partner to give you a result of our research.
The result is about 3 parts. One first is about normal statistic of data. After we apply different data processing tools such as KNIME and Microsoft Access, we get a rough understanding of our dataset. An issue was that there were 140 distinct crime codes which could be complex in dealing. We changed it into 23 different kinds via KNIME, and then split the whole dataset into 2 parts. We kept 1 million rows for later use. These 1 million data have similar performance on different charts with the original one. From this pie chart, we can easily get the most frequent crime codes are 7, 4, 1, 12, which are theft, vandalism, assault, burglary. The second part is about to check and expand our findings in the data visualization software Tableau. This is the crime accuracy in 24 hours provided by KNIME. And we can see the noon is the most dangerous time. But this is about all the arrests and all the kinds of crimes from 2000 years to current. In Tableau, we set classifiers and get more specific results. This Tableau picture shows different conclusion with the overall one. We did the same thing on arrests and crime codes and victims features, such as victim descent and different sex. The third part is about the drawing of the crime map. We firstly pull data on the map and give different colors to different crime codes. The red and orange is for the most dangerous codes, and we can have a detail about the points by putting the mouse on it. Then we use the region map for areas making and combine them with heat map. Here we can see areas with the most crimes. And finally, we add tips on it to show about the top crimes in this area, and this is our final area map. Next part is limitation and recommendation.
Although we analyze the crime data in Los Angeles, however, there are still some limitations to this study. First of all, the big data analysis only shows the probability of crime. We can provide information to police officers by collecting and analyzing data on which aspects are more prone to crimes and what are easier factors to catch criminals. And another limitation is data visualization is a resource and a tool, but it only informs information, not explain information. The correct use and the correct interpretation of information depends on ourselves, but sometimes it will inevitably lead to misunderstanding. And the last limitation is the data we collect and the process is only a tiny part of words. This information is just a projection of reality. The shadow on the plateau cave, we can't get perfect information, so the prediction made are inherently unreliable. So we can solve these related problems by the following methods, like broaden data collection channels, develop a robust big data system, and establish a data sharing mechanism. Now the last part is our reference. Thank you.